more the big picture for statistics, but this video is going to be about relations or relationships. I'm just going to use the word relations because it's shorter. And this video is about relations between two variables. So there's a lot of different options there about the relationships between two variables, but we're strictly going to start with the continuous variables, which means it's a scale, a score, etc., etc. So let's take an example. So we have variable x and variable y. What we're trying to do with a relation check is see if there's a cause and effect going on. We got to be very careful. We can never say cause and effect regardless if we have a very strong correlation, because there's always something else and a different variable out there that could be affecting the results. So I want you to think about this as cause and effect, but don't say cause and effect. So we say correlation, not causation. So cause and effect, in other words, if one variable changes, does this affect the other variable? Here's a good example. Do study hours affect test scores? Are they related? So you would think that the more a person would study, the higher he would get on his test scores. But as we all know, that's not always true. So study hours is causing test scores as being affected. So when one value goes up, what does the other value of the variable do? Does it go up as well? Right? Does one variable increase cause the other variable to increase? Or vice versa? Does one variable increase cause the second variable to decrease? Or does one variable increase not cause the variable to do anything? The other second variable just kind of sits there. So if both variables are continuous variables, and that's a scale or a score, just a regular number variable, we're supposed to use the Pearson correlation. I'll say that again. The Pearson correlation is used in comparing two variables that are continuous, looking for a relationship. We mark that with the little number r. So little r means the Pearson correlation, right? That's the test statistic. There's the formula for it. We're not doing these by hand anymore. You can do them in Excel in the blink of an eye, but you have to have two variables. So x sub I is a piece of data from the x variable, and y sub I is a piece of data from the y variable, and the rest of it is kind of self-explanatory, but there's stuff in the Moodle if you want to look it up. But all you really need to know about the r values is that they describe the relationship between two variables. So if r is close to 0, regardless if it's positive or negative, if it's close to 0, that means that the relationship between the two variables is very, very weak. That means when one variable changes, the other one does not change at all. It just kind of sits there. Now, on the other hand, if r is closer to 1 or negative 1, the stronger the relationship. So the greater the value of r, the stronger the relationship between the two variables. And if r is negative number, right? If r is less than 0, that means you have a negative relation. So that means when one value goes up, the other one goes down, or vice versa. When one value goes down, the other one goes up. If r is positive, greater than 0, that's a positive relation. And what that means is when one value goes up, the other goes up. Or when one value goes down, the other goes down. They both go in the same direction. That's called a positive correlation. And don't forget about your scatter plots. They're all connected, correlations and scatter plots. To make a scatter plot, you make a y-axis and an x-axis. The y-axis is always your second variable, right? Your response variable. It's your y value. And your x-axis is always your cause variable, whatever you want to call that. And then you would generate points. Remember, every point on a scatter plot has two dimensions. It has an x value and a y value. So if these were cats and birds, the more cats a person has, the less birds that are around. So if you had 8 cats in the neighborhood and you only saw 3 birds, and then the next day you saw only 2 cats, but then you saw 6 birds, that is a 2-part data set, right? So you're going to graph these things. They're coordinates now. And let's just pretend you had weeks of data, and each one of these is a data point, right? What comes next is a best fit line, also called the best fit line of squared regression, also called least squares line of regression. It kind of goes by many names, but basically it's the best fit straight line that goes through these points. And I just drew one in there by look, but the way we do it is mathematically driven, and Excel does a great job, so don't worry about it. But you'll notice that some of these points are not close to that line. That is a bad sign. The distance between a point and this line here is called the residual, and it's actually how far off this point is from this predicting line. That's what we're going to call this line, the line of prediction. So this point isn't a good point according to this line, and there are others that are kind of way out there. You might even consider these outliers. So what would happen is this line has an equation. If you remember from your algebra class, you would make a prediction equation using your y equals mx plus b rule, and we use this to try to predict. So if we know x variable values, we could plug them in. Let's say this was 4 or something. If we plugged it in 4, we would go up to the prediction line, and where it crosses on the y, that would be our predicted y. That's what this whole chimichanga is about. And again, back to algebra, y equals mx plus b, where m is the slope and b is the y-intercept. Except for with this, we flip it around just to confuse you. A is now the y-intercept. That's where the value is before you start measuring. When x is 0, that's what your A is going to be. And B is the slope. It's also called the correlational coefficient. It's not the correlation by itself, but it's related to the correlation. But B is the correlational coefficient. And what this whole thing is trying to do is to make a significant prediction model. If it can. They're not always good significant prediction models. Good prediction models, these points would all be real close to this line, real close to the line. That would make this prediction model very accurate. Just the opposite. If these points were way, way away from the line, that means your model is probably not accurate. Get back in there, line. But you got it, but the numbers tell everything. So in a nutshell, a correlation number close to 0 means you've got a very weak correlation. It's not going to be significant. A larger correlation, whether positive or negative, is a stronger correlation, and you might get significance. The last thing I'm going to say about this is if you get a correlation of 0.1 that's considered weak, 0.3 that's considered medium, and 0.5 that's considered a strong correlation. And that's about it for correlations for now. Okay, MGZ out.